All right. So this course, I believe, in like the course catalog, is called Quantitative Business Analysis, which is fine, but you'll notice your text says Applied Management Science because that's kind of what we're studying, right? We're studying applied management science, and it's a discipline that takes the scientific approach and applies it to the discipline of management. Right? Try to do things the best way. And if you had maybe in your MBA500 class or maybe in an undergraduate class, you may remember stories about Frederick Winslow Taylor in scientific management and trying to figure out the one best way to do something. And that's what we're going to try to do with the models that we built. We're trying to help managers make informed decisions. And one thing I'm going to point out a lot through this class is we're going to build a model, we're going to come out with a solution, and as managers, though, we have to understand that that model was built on a bunch of assumptions that may or may not hold, and we have to understand that we're not a slave to the results of that model. We have to use both the information it gives and our own expertise and knowledge to make the best decision, to recommend the best course of action. Okay? So there's really three basic steps in this process. Okay? The first one is to analyze the situation, analyze the business situation. There is some problem. There is some gap between ideal and what we're doing today. Okay? Building a mathematical model to describe that, so I guess we could say four stops. Solving that model, and then looking at the results and making a recommendation. Okay, that's the process. We're going to look at the problem, build a model, solve the model, look at the results of the model, make a recommendation, implement their solutions. Now, there are all kinds of examples of how this is done in the business world, and it has just continued to increase because we generate so much data now. If you think about it, when you bought something downstairs and you used a card, that generated data. They know you're at St. Francis right now. Your cell phone is generating data right now. Whenever, if you wear a Fitbit, that's generating data about you right now. So good companies use that data to make better informed decisions, and that's what we're going to do a lot in this class. These are some old school examples, and you'll see, remember I told you this text was old. Some of these companies, you're saying, well, that company's out of business now. But anyways, some of the things that we're going to talk about using linear programming, which is what we're going to first be introduced to say, how do I best blend these things? They're talking about cuts of meat for Burger King to make sure that it has these standards, these calorie standards, these protein standards, yet cost me the least amount of money. Talk about like logistics, and we're talking about like flight schedules, like what's the optimal way to get items across the country from point A to point B through maybe point C, D, and E. And we'll talk about those kind of things. The shortest route algorithm is another example of that. We use some of these algorithms daily. When you plug in a route in your GPS, behind the scenes, hey, it's using the shortest route algorithm, how to get from State College to Detroit, Michigan, the most efficient way. That's the shortest route algorithm. We're going to talk about project scheduling techniques, PERT CPM, Program Evaluation Review Technique, and Critical Path Method. There is a whole standard litany of a standard project management body of knowledge. We're going to tap into some of that and look at the mathematical models, how we schedule tasks, how we define what the critical path is, and as a manager, what does that mean to us? So we'll talk about that. It talks about a contractor using project scheduling techniques to build a highway. We're going to talk about decision analysis. We have, as a manager, we have a finite set of decisions. Those decisions may result in one or more outcomes. Using not my gut approach or some political approach, but using a quantitative approach to say, if we're pessimistic, go with this. If we're optimistic, go with this. So try to apply a model to that so it takes out emotion and subjectivity. Queuing models, we'll talk about those later in class. Queuing models, queue is a study of a line, right? So you go to Sheets, they've done queuing analysis, right? They're a convenience store, so how long people spend at Sheets is really important to convenience. Disney World has done a lot of queuing analysis. We can also talk about networks and how long things are in different places. Interstate highways and toll roads all lead to queuing analysis models. Now, I'm going to come back to this. I'm going to skip ahead. There are ways we're going to use these models. I keep talking about models, but before we get into some of this, we're going to classify models first. Okay? And the two major classifications of models are by the purpose of the model. The first type, and that's what we're going to get into first, is something known as optimization models. Optimization models is picking the best option, right? What is the best option to maximize profit, minimize risk, maximize user satisfaction? That's an optimization model. We're going to build this model and try to find the one best way. Try to look for the one best way, the optimal solution, the best solution given the model that I built. We're also going to use prediction models. Prediction models, we're going to talk about that when we talk about forecasting. Think about all the prediction models you see daily. You go into Amazon and it says, hey, we think you may like this. Well, how did that come up with that recommendation? Through a prediction model. You go to Netflix, it says, hey, movies that you may like, or Pandora, the songs that you may like. Those are prediction models. How many incoming students is St. Francis going to have? How much demand are we going to have for our product next month? How much, all these things are prediction models. So not optimizing, but trying to look into the future based on the past. Those are prediction models. So those are the two types of models by purpose that we're going to focus on in this class. First, we're going to focus on optimization models via linear programming, and then we're going to come back to prediction models. The other way we can classify the model is by the degree of certainty in the model. So there's two types there. There's deterministic and stochastic. Okay? Stochastic also is probabilistic. Deterministic models are, I know that every 5 minutes this happens, right? Always every 5 minutes this happens. If I am a doctor, perhaps, I try to set up my appointments so they're 5 minutes long. Determined. The arrival pattern is determined. If I'm Sheets, I don't have that luxury. I can't say one customer every 5 minutes. They come in according to something called a quant process, where some, one time you might get 20 people, and next 5 minutes you might get 2 people. Okay? It's a probabilistic model. So we have to build that in, right? We're not always certain it's going to be this much. So you'll see that when we talk specifically about project management models. If I asked you how long is it going to take you to do something, you may say, it's going to take me 2 weeks, Dr. Miko. But are you guaranteed it's going to take you 2 weeks? You're not, right? Because maybe you get it done early, maybe you get it done in 5 days. But maybe you get it done late and it takes you 3 weeks. So when we build our project management model, we want to build in that uncertainty. We're going to say, hey, on average, it'll take us 2 weeks. Best case, 5 days. Worst case, 3 weeks. So we want to build that into our model so we can understand the probability that the whole project is done within a certain time frame. So these are the types of models that we're going to be discussing in this class. Now, it says the 4-step approach. And one of the things that I don't focus on in this class, even though the book does, is this part. Okay, communication and implementation of results. I found through teaching this class is that MBA students, and specifically the millennial generation, are very good at communicating. Okay, I think that communication is a strong tool. So we'll see that when we do the final project. But the first 3 steps are what we're going to focus on in this class. Okay? So let's talk about the first kind of model that we're going to cover in this class. It is called a constrained optimization model. Okay. And you'll be surprised how many things fit into this model. That's why we leave off with it. When we look at a situation, we try to define 3 things. Okay? 3 things and 3 things only. First off, we try to decide or determine what we can decide. Okay, there's things I can decide as a manager, and there's things that are beyond my control. I may be able to decide how much of product A I produce and how much product B I produce, but things that are just factored in are, well, I know product A uses this much material and this much time, and product B, I can't change that. That's not something I'm trying to decide. So we have to determine, what can we change? What is our decision? What are the variables, what are the conditions that we can change as a manager? The second thing that we need to decide is what we are trying to optimize. What are we trying to make optimal? And some managers might look at the same situation differently. Some might say, I want to maximize employee satisfaction. Some say I want to minimize expenses. Some say maybe I want to maximize product reach. Some say I want to minimize the advertising cost. Okay, so we need to decide what we're trying to optimize. And the third thing, which is kind of the most difficult thing, is what am I bound to? What are the constraints? What is holding me back? I only have so much product. I only have so much time. I only have so much money. In the business world, we're always presented with these kinds of things. I only have so much time, money, talent, all those good things. So I got a little bit ahead of myself because that early break screwed me up. But what I want you guys to do before we get into an example of this is let's take, and I don't think I have copies because a lot of people signed up late, but I'm going to pass these around. And I want you to take 10 minutes and you can work with each other. I want you to try to solve those three things. Three like riddle-ish type of problems. It's on Blackboard as well. I'll bring it up on Blackboard, but you can work each other, talk about it, try to solve it, come up with some solutions. So this is under material by chapter, under chapter 1, and this chapter 1 handout. So the first one, I have 13 coins in my pocket, can be any US coins, a total $1.19. What are the coins? I think the air conditioning is on, US coins? I think it's on, yeah. That feels on. So who has a solution? Yeah? Well,
4 pennies.
4 pennies, okay.
3 nickels.
3 nickels.
5 dimes.
Uh-huh.
And 1 50 cent.
Okay, so that is a solution. Anyone else have something different? Mr. Wolf?
I agree with 4 pennies, 2 quarters, 1 nickel, and 6 dimes.
Okay, anyone else?
I had 3 quarters, 2 dimes, 4 nickels, and 4 pennies.
Anyone have any with 9 pennies? There's one, I can't remember what it is right now, but there is one. No? All right, so a couple things. What that was meant to show you. How did you solve that? Many of you solved it, right? How did you solve it? Trial and error. Okay, so trial and error is a valid model solution technique. And actually, when we use solver, it's doing trial and error just a lot faster than you and I can do trial and error. Okay, that's what it's doing behind the scenes. But what helped you with that trial and error? You didn't try every combination. What helped you with that trial and error? What did you know? What was something you could hold on to that kind of simplify things a little bit for you anyway? What did you know?
It's gotta be at least 4 pennies.
Yeah, you knew because it was $1.13 that this here was either 4 or 9, right? Or not 9. Yeah, 4 or 9. Yeah, it's $1.19. Yeah, it had to be 4 or 9. So that made it a little bit easier, right? You took that out of the equation. And sometimes we have to do that when we build a model. Sometimes there's something we say, well, we can kind of take this out and just hold that to be true, right? Just hold that to be true, and it makes things a little bit easier. When we build models, sometimes we're not going to be able to capture everything. The other thing this was meant to show you is trial and error is a valid approach. Sometimes they hold on to things, and sometimes there's more than one solution, right? And that's what we see here. I think there's like 5 or 6 solutions to this problem. And that's fine. These are all solutions. Sometimes we're going to be presented when we solve a model with multiple solutions, which is a good thing. Or solutions that are nearly all optimal, because then we can pick the best of the best, right? We can pick the best of all the optimal solutions. So that's what that was meant to show you. Let's look at the second one. Okay, a farmer has been given 100 feet of fence to use for his new herd of sheep. What dimensions should the rectangular fence have to maximize the grazing area of the sheep and the area of equal length times width? What is the answer to this one? Yes, okay. So what if I allowed you to say like a square is actually just a special rectangle? That would be 25 by 25. Okay, so and a square is just a special rectangle. So the answer to this is 25 by 25, which gives you an area of 625 feet. How did you solve that, sir?
I just started off with 30, 20, and I don't know my R went, just the number got lower. So.
Okay, so you're trying to find that sweet spot and zeroed in on that trial and error approach. Did anyone just know that? Did anyone just know that, hey, a square maximizes the area? Do you know that? Okay. If you kind of know something, and that's a known thing, right? It's a known thing that's called heuristic models, right? Heuristic means, and it stands for H-E-U-R-I-S-T-I-C, heuristic models, which kind of means rule of thumb, right? And I'm sure in some of your jobs, there are things you say, our rule of thumb is this. You know, we get down to 20%, we order new inventory. So rule of thumb, heuristic approaches are also valid approaches to solving models. So that is what we want to use here. How about the last one? So another farmer produces corn and barley. A lot of farm questions tonight. The seeds for the corn cost $100 per acre to plant, and the seeds for the barley cost $50 per acre to plant. The farmer has 80 acres of land and $5,000 to spend on seeds. The money is a government subsidy, so he has to apply it towards the corn and barley that we give back to the government. Corn yields a profit of $80 per acre, and barley yields a profit of $60 per acre. How much of each should he plant to maximize his profits? So, sir.
24,
And you make a profit of $5,200. So that is the right answer. How did you come up with that?
Just needed to maximize the amount of corn. So I looked to see until I got $5,000.
Okay, by doing the corn. So you did a little bit of trial and error.
Yeah, I just started at corn and working on it.
Anyone else solve that? Anyone else get the answer? So did anyone else use Excel? Did anyone use Excel at all for that? So trial and error, how did you do trial and error? You just wrote things down? Use your calculator? Okay. Well, if we look at something like Excel, and you can do that pretty easily by saying, all right, let's start with a value, and then they have to add to 80. We know we have to use all the land, and put a little equation in here for cost. Hey, we know this is no good because it costs too much, gives us $1,500 profit. Keep looking at all the combinations for 80 acres, until we get something that says, all right, hey, we're spending 5,000, 5,200. Hey, if we tweak that a little bit, 19 and 61, hey, we're still spending under 5,000, but we're making less. That's the sweet spot. Right there is the sweet spot. That is the optimal solution. That is the one best way. Plant 20 acres of corn and 60 acres of barley, and that gives us $5,200 worth of profit. Now, what we're going to use, besides trial and error or working on our calculators, is we're going to use a constrained optimization model to solve this, right? And we're going to use, for our solution technique, we're going to use something in Excel called Excel Solver. But before we get there, and this is the hardest part, we need to go from, hey, this is the problem that was presented to the farmer, kind of a simple problem. We want to go from that problem to a quantitative model. You think about that, step one. Go from this word problem to a quantitative model using these three things. So let's ask this. What can we decide here? What is the farmer trying to decide? Nope.
Or how much of each?
Very good. That's what the farmer can control, right? He or she can decide how much of each to plant. That's the decision. How much of each to plant. Okay, that's the decision that this farmer is trying to make. What are we trying to optimize in this case? This should be an easy one. What are we trying to optimize? Make optimal, make big or make small? Profit, right? We're trying to optimize the profit. And what are we bound to? What is holding us back? And that's, everything in life. There's always something straining. What's holding us back?
They only do corn or barley from the government.
Okay, so corn and barley. And what else about the corn and barley? What are the things that are constraining me in my little farm? We know we're planting corn and barley. Yeah, I know there's other solutions, but we're kind of simple. You can plant other stuff. But let's just say in the world of corn and barley, what else? Katie?
80 acres.
That's a constraint, right? 80 acres. We can't plant more than 80 acres. That's something holding us back. What else? Yeah. And the seed money. We only have $5,000 for inventory. So these are the things that are holding me back. Okay, these are the things that are holding me back. So that's good that we can go from that problem to these three things, to parse that apart and go to these three things. But the next thing we want to do is we want to quantify this so that we can build a model. So let's do that next. Okay? This first part that I've been calling, in the world of constrained optimization models, we're going to call this first part, you'll see me write it all the time as DV. That stands for decision variables. Decision variables are the things that I can decide. And the reason it's variable is because variables change, right? X can be 0 to 1,000,000, okay? Decision variables, they can change. When you looked at my spreadsheet, it said 3050, 2961, 2862, or it would be 1862. It was variables. They were changing, okay? Decision variables. In this case, what are our decision variables? We need to define decision variables. What are the two things? How much corn to plant and how much barley to plant. So what I'm going to do is up here I'm going to say, okay, C is equal to the number of acres of corn to plant. And we're going to say B is equal to the number of acres of barley to plant. Now, I use C and B, but you could use X and Y. I don't know why you would. You can use C and B or A and C. It doesn't matter. But as long as you keep it consistent, you have to define decision variables, like the things that I'm deciding in a variable format. C and B in this case are the things we're going to use. So what are we trying to optimize? Okay, the optimum. We're going to call this thing the objective function. And I know you've heard the term function before. A function, is an equation. It's not an equation, it's a function because it doesn't have the, it's not, but it's a function, right? It does something. So the objective function here, the objective is to maximize profit. But profit is something that math doesn't understand. It's a word. So I want to create a function that represents profit. Not profit. I want to substitute that with a function. What would that function be? What would that function be? For every acre of corn I plant, I make how much? $100. For every acre of barley, I make 50. So what would that look like as a function in terms of C and B? Nate?
100C plus, 100C plus was 50.
Yeah. Isn't this what you were doing? You're saying, if I plant 1 acre of corn and 1 acre of barley, hey, it's $150. 2 of each, that's $300, right? That's the equation. That's the function that we want. Yes. Make sense? The last thing, so this is 1 from here, this is 2, and this is either going to be max or min. We're either going to maximize something or minimize something. And the third thing we use are the constraints. We call this area the constraints, the things that are holding us back. And you'll see me use the letters ST, and it depends what text you're using. It usually stands for subject to, like subject to these constraints, or such that, depends on interpretation of it. But you'll see ST there. So you guys told me the constraints are 80 acres. So here I'm going to make an equation, and I'm going to say 80 is on the right-hand side. Whatever we use has to be less than or equal to 80. Well, what's the equation or the function for what I'm using? If I plant an acre of corn, how much acreage should I use? 1. If I plant an acre of barley, how much acreage should I use? So 1C plus 1B is less than or equal to 80. Make sense, right? How about the second constraint? Less than or equal to 5,000. That's the seed money, right? Can't go over that. That's what's called an upper bound constraint because it has an upper bound. What would this side of the equation look like? What would it look like? Oh, wait. The profit is, I was using the wrong. The profit is, yeah, I know it was. Corn yields a profit of $80 per acre, so this should be 80, I'm sorry. And the barley yields a profit of 60, I'm sorry. The cost numbers are 150. So down here, we're going to have 100 C plus 50. Okay. So think about it mathematically. We've taken that and modeled it mathematically. We haven't solved it. All we've done is go from a concept, a business concept, an agricultural concept, to a mathematical model. If I plant an acre of corn, an acre of barley, hey, I make $140. 2 is less than 80, I'm good. 150 is less than 5,000, I'm good. Right? If I go to 10 and 10 of each, hey, I make 1,400. This is 20. This is 1,500, I'm still good, right? If I plant 100 and 100, oh, I blew out my acreage constraint, right? This models that situation, does it not? It does, okay? The other thing that maybe isn't intuitive to you, but would also add another constraint typically to these models, and it's called the non-negativity constraint. So I'm going to add it to the bottom, and I'm going to say C, comma B has to be greater than or equal to 0. And what this means is I can't plant negative acres of corn or negative acres of barley, right? That makes sense. Okay? Does that make sense, right? So the combination can't be plant negative 20 acres of corn and 100 acres of barley, right? So we have to hold to that because that's real life. I can't do negative planting of stuff. Okay. Sometimes there's other constraints. We'll talk about that next class. All right. So there you go. That is the model. But remember, the important step is come up with a solution. There's a couple ways we can solve this. One way we can solve this is I could graph this area. This is what we call the feasible region, and then pick the optimal point. That's a real pain in the butt. Okay, it's a real old school way of doing it. We're going to do it next week. I'm going to show you how to do it next week. But that's not typically the method we're going to use to do it. Okay, we're going to use Excel. I'm going to show it to you. Why I'm going to show it to you is it helps explain something we do later called sensitivity analysis. What we are going to use to solve this is something called Excel Solver. So I'm going to go over here into Excel, and it looks like I have Excel 2016 here. But as I said, anything 2010 or higher will work. Now, Excel is a wonderful tool that many people use. It comes with certain add-ins, okay? Add-ins or add-ons, I think it is. I can't remember if it's add-ins or add-ons. But add-ins or add-ons are increased functionality that is turned off when they install Excel. And the reason they turn it off is because it takes extra memory, and 99% of the population doesn't use them. But welcome to the 1%. So we need to turn on that functionality. So if we go to, and this is different, but most of them, it could be an Office button, I think, if you're 2007 or 10, I can't remember. But we're going to go to File. This is a one-time deal. Options. And we want to go to Add-ins. You guys see Add-ins? Okay. And down at the bottom of this, you see it says Manage Excel Add-ins. Mac has some different keys, so it works. It'll work on the Mac, but some keys might be different as we do some of this stuff. Okay. And I'm going to click Go, and then it says, "Hey, Kate, here are add-ins available that come with Excel that you have turned off. Euro currency tools, analysis tool pack. That's for like descriptive statistics, analysis tool pack, VBA, and the one we want to turn on is the solver add-in. And while you're in there, also turn on the analysis tool pack VBA. And Euro currency tools if you're going to Europe. So click OK. And it should, if you have a legal version of Microsoft Office, and I thought this would happen faster, it should. So File, Options, Add-ins, Go. We're checking Analysis Toolpack and Solver. Now, you know it worked if you now have under your Data tab, on the far right, you have a group called Analyze that you did not have before. And that grouping should have Solver in it and Data Analysis, because that's what we just turned on. Yes? Under Tools, maybe? Tools, Options? You see it? And the Mac stuff looks a little different. It still works, but it's different. Some of the hotkeys or the function keys are different. And I don't remember them, but you can always Google them and say like, hey, what's that for in Mac world? That's what I have to do. Anyways, okay, so now we have this solver add-in. I'm going to click on it just to show you what it looks like, and then we're going to invoke it. So a couple things. We're going to take this model we put on the board, we're going to translate it over into Excel world, then we're going to invoke solver to figure it out for us, to solve it for us. We have to tell solver about those three things that we wrote on the board. First off, set objective. What do you think, which part of this model is the objective? The second part, right? That's what we're trying to optimize. By changing variable cells, what cells am I going to let it change? The ones I can decide. Subject to the constraints. So those three things need to be captured up here. Before I can do that, however, I have to kind of take that mathematical model I built on the board and build it over here in Excel. So we're going to do this next week as well. All right, so I'm going to go through this. I'm going to go through it fairly slow. I'm going to record it. But we're going to do this a lot. So if I lose you, don't panic. Don't say you're going to be lost, because even for homework for next week, I don't ask you to solve these models for next week. I'm going to ask you to set these things up like I did up here, understand this process of modeling, but then next week we're really going to start solving these kind of models. Okay? So let's give this a try. I'm going to just, for clarity purposes, I'm going to go over to C1, and I'm going to just type a label. What do we use? Corn. And in D1, I'm going to type the label bark. These have no function to them. They are simply labels. Okay, so I'm going to go nicer. Corn and bark. Okay, just labels. In C2 and D2 is really where my decision variables are going to live. And I'm going to just start by saying 1 and 1. And the reason, I just want to prime that basically. I'm just going to say, let's say we plant 1 acre of corn and 1 acre of barley. So C2 and D2 is where my decision variables are going to live. Okay, C2 and D2. Okay, and I'm going to skip a line for clarity purposes. And I'm going to put the word max, and this is, once again, just the label. And so I'm going to max. And when I put this on the board, I don't know if you noticed this, because I didn't do a crazy nice job of it, but I tried to keep these things lined up. Okay? I tried to keep the corn in the same column and the barley in the same column. Because that's what we're going to do when we put it in Excel. We're going to focus on the coefficients, the number before the letter. Do you know what I'm saying? So we're going to only put numbers in these cells, and the coefficient for the profit is 80 and 60. So in C4, I'm going to put 80, and in D4, I'm going to put 60. All right. Now, what I ideally wanted to do is, hey, I want to decide, I want to change this, and I want to see my profit change, but I don't have a profit cell yet, right? You see no cell up there that represents profit. I want E4 to represent profit. Mathematically, how do I make E4 represent 1 acre of corn, 1 acre of barley? I want it to say 140 right now. And if I change it to 2 and 2, I want it to automatically change to 280. How do I do that in Excel? And I know some of you are very proficient in Excel, and I know some of you maybe have barely used Excel, so I'm going to teach down this level for right now, okay? So how do I do that? How do I put a formula into Excel? I start with equal sign, okay? And there's a better function to do this that I'm going to show you in a second. But for right now, I'm going to say, take whatever's in C2, which is 1, and I'm going to multiply it. Multiplication is an asterisk, times whatever's in C4, which is that 80, plus, and I don't put any spaces ever in an Excel formula, whatever's in D2 times whatever's in D4. Okay, so whatever's in C2 times C4 plus whatever's in D2 times D4. There's a much better way to do this, but let's walk before we run. I hit enter, I get 140. Let's see. If I change it to 2 and 2, oh good. Changed it to 280. If I change this to 20 and 60, there's that 5200 we talked about. If I change it to 50 and 50, it's adjusting, right? It's doing what I want the model to do, right? That's what we want to do. In this cell here, that I'm going to give I'll give it a cell style. That represents my profit, right? I'll put a little label next to it so we know. Put it above it. It's profit. That's my profit, and that's all just. Make it look nice. So I have captured decision variables and the objective function up here. Does that make sense so far? Yes. The third thing I want to capture is my constraints. So I'm going to skip a line, and I'm going to put ST for subject to. And I need, once again, to focus on the coefficients. So the first constraint I'm going to try to capture is this one. What is the coefficient for corn for that constraint? It is 1. For barley, it is 1. When it goes in E6, I want E6 to represent the amount of corn and barley I planted. What would that equation look like? I know this is the long way to go through it. I'm going to do it the long way. C2 times C6 plus D2 times D6. Obviously, we're going to use some copy and paste and make formula static, but at this point, let's just pretend like we can't do that. And I get 2 acres, so that makes sense. So if I change it to 10 and 10, it looks like things are working, right? 1,400 profit, 10 acres. But this is a little special, right? I don't just want to say, I'm going to copy it. I just don't want to say like, hey, it's 20. I also want to indicate the 20, and it has to be what? What about the 20? Go ahead. It has to be less than or equal to 80. And notice I put the 80 as a number in a separate cell. Don't put less than or equal to an 80 because the cell will interpret that as text. I want to make sure it treats this as a number. Okay, so I put less than or equal to here, and I went over and I put 80. Does that make sense? Okay. Let's capture the seed one. Coefficients are 100 for corn, 50 for barley. And if I do equal C2 times C7 plus D2 times D7, it represents my, represents my seed money. We know that that has to be less than or equal to 500. All I've done at this point, I haven't really done anything except translate it from whiteboard, which I can do nothing with, right? I don't have any magical powers to do anything with, to an Excel spreadsheet, which has incredible what if analysis ability. So if I change this to 1 and 1, if I change this to 1 and 1, you'll see, hey, it's changing things appropriately. I change it to 100 and 100. It changes things appropriately, and you're seeing, hey, I'm making $14,000 profit, but I'm blowing my acreage and I'm blowing my budget for seed money. Does this make sense? So as a human, I could do trial and error and look at this and say, okay, eventually arrive at 20 and 60, but I don't have that kind of time, and I could do it probably with something like this, but sometimes we have models that have 5 or 6 decision variables, and those 5 or 6 decision variables have hundreds of options each, and 100 options each, and times 5, that means we're talking about billions of combinations. I don't have time to do that, so I'm going to use something that does have time to do that, and that is where we're going to invoke Excel solve. Okay, so is everyone's model working? Or don't panic if it's not, because we're just trying to emulate this with Excel. Okay, so now is when we solve it. This is when the magic happens. I'm going to go up to Data, and I'm going to click on Solve. So it's good to have something in your life called Solve. Okay, and it wants to know where these things are. So the first thing it wants to know is, what are you trying, what is the objective here? And it wants to know one cell that represents the objective here. What one cell represents the objective here? E4. So I could either type E4 here, or I can highlight that, what was in there, click on the little spreadsheet next to it, click on E4, and click on it looks like you're closing a window, and it'll put E4 in there for me. But however you get there, get E4 in there. That represents profit. That's the one cell that represents profit. And I need to tell Excel about that. There's a little radio button here, an option button. Are we trying to maximize or minimize in this case? In this case, I'm trying to maximize, so the default is good. It's all right. I'm okay. Okay, so I'm just going to leave that alone. By changing variable cells. Where are the cells, the decision variables up there that I'm going to allow Excel to change? C2 and D2. When I put a range into Excel, I use a colon to indicate a range. Or, and that's what I'm going to do, I'm just going to click on this little spreadsheet. I'm going to highlight C2 and D2. And I'm just left clicking and dragging there. I'm going to click the drop down and put in there C2 through D2 for me. Okay? Now at this point, if I try to solve it, what it would do is say, all right, you're trying to maximize profit, plant an infinite amount of corn, an infinite amount of barley, and you're going to make an infinite amount of money. But that doesn't represent real life. I have acreage holding me back, and I have money holding me back. So I need to go down to the third part and tell it about those. This is the most funky interface, I would say. So we don't have anything in our constraint area. You see this big block? We don't have anything in there at this point. I need to add some constraints here. So I'm going to click on Add. Okay. And we need to tell it about both sides of the equation. So we first need to tell it about where is the resource that I'm using. So where is the total acreage? Well, the total acreage on this first one is represented by cell E6. And E6, you notice there's greater than or equal to and other options, but just leave it less than or equal to. Has to be less than or equal to what in this case? 80, but instead of saying 80, I want it to point it to where 80 lives. So where does 80 live? G6. So E6, whatever the hell's in E6, has to be less than or equal to whatever is in G6. I don't like this, but now when I click Add, it goes away, but it doesn't give you a message to say like, hey, constraint added. It just goes away. It's not really good programming, but anyways, it added it. I can tell you that. And I'm also going to tell it about the second one. I'm going to say E7 has to be less than or equal to, and I have to click to get over that right-hand side, G7. I'm going to click add, and it just goes away. I'm going to click OK. Whoops. I'm going to click cancel, and it takes me back to the previous interface. So now you'll see our total model set up. It says maximize E4 by changing cells C2 to D2. E6 has to be less than or equal to G6. E7 has to be less than or equal to G7. It makes sense now why I kept things in line, right? Because it made sense now why we try to keep things in line. The last thing I want to change, well, see this box here, this make unconstrained variables non-negative? By checking that box, I've added this non-negativity constraint. We can't plant negative acres of corn and barley. And there's different methods that it uses to solve. Some of yours may default to simplex LP. If it doesn't, make it simplex LP. Okay, so GRG nonlinear in this case would work as well, but let's make that simplex LP. Get the habit of doing that. It's using some method called the simplex method to do trial and error. Okay? And now the moment of truth. So if we click solve, and you did things right, you get a okay chime, I guess. It says solver found a solution. All constraints and optimality conditions are satisfied. Keep solver solution. Sure. Click OK. And you'll see it says the one best way, the optimal solution is what you arrived at. Plant 20 acres of corn and 60 acres of barley. You'll make $5,200. You use all 80 acres and you'll use all $5,000. Now, Lance, you have a question, or you? No. Okay. Now, what's beautiful about it being in a spreadsheet now, what if things change? What if, for whatever reason, we expected that we would, that barley would become more profitable because there was a drought. So we changed that to 150. Well, is 20 or 60 still the optimal solution? Well, let's see. If I click solver, and I click solve again, now that I have that model built, it says, heck no. That was the cost. I'm sorry, that was the cost. Now let's move all the production to corn. Okay, that's the best model in this case. It also, when you get a solution like this, and we're not going to do that this week, but let me just go back to the original solution. What was this, 50, right? I'm going to resolve. Okay. When I get a solution like this as a manager, someone comes to me and says, the one best way is 20 acres of corn and 60 acres of barley. As a manager, what other questions would you ask? Okay, just roll with it.
We actually got made.
Okay. True. What else?
How do you get there?
How do I get there? What were the assumptions behind there, right? You think about this kind of situation, when we treat these models, we kind of treat them as exact, right? But heck, if we're planning something, we can predict the amount of money I'm going to make on it, but I don't know, right? I don't know what's going to happen. So that's just a prediction. So yeah, we're going to want to discover that. But even inside this model itself, I go to my boss and they say, okay, $5,200. What would that boss be pushing for? What would she push for, or he push for? More, right? So what might they ask? What if we were able to, lease another 10 acres? What does that do? Okay. How much more money does that make us? So if it costs under that, let's do it, right? And they might say, well, what if we were able to acquire more capital? And if that capital was another $5,000 and it had a debt charge of 50, is it worthwhile to do, right? So not only are we going to have a solution, which is great. But what we're going to do mostly in week 2 and week 3 is we're going to have a solution, and we're going to try to really analyze that solution and say, hey, this is the solution, and here's what we could do differently, or this is where the solution is valid for, and this is where it would not be valid for. So we can go down like another layer and answer a bunch of like what if questions. Okay, what if questions. And I know that was their first time through that, but and it may look difficult, but like I said, by the end of this class, if you get problem 3 on the exam, you'll be like, wow, that's a piece of cake. Okay, so students are always wondering like, okay, all right, we learned a little something. How am I going to test that? Well, on the out-of-class test, right? We talked about like the midterm will have an in-class portion and an out-of-class portion. On the out-of-class test, I would want you to come up with a solution, right? And further, there'd be a series of like what-if questions that I would pose to you, like as if I were your boss. And I would want you to come up with a solution to that or a response to that. Like, hey, what if I get another 10 acres, right? And I'll teach you how to analyze. There's reports that come with this, and I'll teach you how to analyze those reports. In class, I'm not going to make you solve this with Excel, but the ability to go from the narrative, from the business problem, to what these 3 things are, that's a skill that I can test. I can assess that, right? That you understand what those 3 things are. So I can assess that on an in-class exam. Does this make sense? But you won't have to solve it on the in-class exam. Okay? So any questions on that? Did everyone come up with that answer? All right. Let's add a couple more things to this. And I'm going to save this just because I should. Okay. So when I did this equation, a couple people kind of like said, oh, I just done it wrong. And they're right. I'm doing it wrong. So anyone have a better way to do that equation? Anyone have a better way to do that equation? Oh, good. It's I do. They're definitely on time. Fill it out. You guys fill it? Yeah. There is a function that does exactly what I'm trying to do here. So I'm going to put the equal sign in, and I'm going to write out the function. It's embedded into Excel. It's called sum product, S-U-M product. And what it does is 2 things. Product, it multiplies like we want, and it adds like we want. So it does sum and product. You give it 2 ranges, and it'll sum product those 2 things together. Now, it wasn't that cumbersome for us to do. Basically, we had to multiply these 2 things plus these 2 things. But what if we had 10 decision variables? Well, that would be a big, long, pain in the butt equation. Well, with this sum product formula, we could specify array 1 and array 2. So we're going to sum product together, C2 through D2, comma, C through D2, comma, the period, not the comma, C4 through D4. So what this is doing, the sum product formula is saying, take C2, D2, that range, and multiply and add to this range down here, these 2 different arrays, okay, these 2 different ranges. I hit enter, and it tells me 5,200, which is exactly what I wanted. I don't want to have to type that formula 2 more times. I would, but I don't want to have to do that. I'm going to copy and paste it down. When I copy and paste it down, though, it's going to screw things up. Let's do it. I'm just going to copy it down. So I'm going to Control C, or however you copy, and Control V. And let's see what happens. If I go to that equation now, now it's sum producting C4D4 and C6D6. That's a problem because I'm going to still multiply by C2 and D2. What happened there when I copied it down? Excel uses something called what? Relative addressing. And because I copied down 2 rows, it copied everything down 2 rows, and it adjusted the formulas appropriately. So what I'm going to do is, before I copy this formula, I want to lock in part of it. I want to set it to static or absolute, or whatever word you want to use. What part of this formula do I want to lock in? Do I want to make absolute?
C2, D2.
This range, right? I always want to multiply by the decision rate. So the way we do this is, I'm going to highlight just that part of the function, the formula, and I'm going to hit the F4 function key. And this is on Mac. I don't think it's F4. I don't know what it is. It's like Apple key, control, put your iPod in. But there's a lot of steps to it. So I'm going to hit F4, and it's going to put dollar signs around both the columns and rows. And that says to the formula, when I copy you, leave that part absolute. Don't change it. I'm going to hit Enter. I'm going to copy that down, Control C, Control V, Control V. And now you'll see it left the C2, D2 alone, but it changed the second part of the reference, which is what I wanted to happen. Now, the beautiful thing about that is, if there were 10 of these, fantastic. The formula looks the same, except instead of going from C2 to D2, I'm going from C2 to M2, right? Same amount of text. And even if there were, 30 constraints, all would be a matter of copying or dragging down, and we'd have that, okay? I just wanted to show you those couple quick Excel things, but like I said, we're going to be spending a great deal of time next week on this. All right, so I usually do that, but I'm not going to do that tonight. All right, let us look at the homework for next week. Okay, so on page 40 through 43 of your course text, the problems I want you to do are 3, 5, 6, and 7. And what these problems, you're not going to have to use Excel to solve these. What you're going to basically do is go from like the corn and barley portion, the word problem, to this. Okay? I want you to start thinking about those 3 things. What are we deciding? What are we trying to optimize? And what are our constraints? So on page 40 to 43, I want you to do 3, 5, 6, and 7. As well, if you're not real familiar with Excel, like I said, this book is old, so it's based on, Excel 2000 or something. It has a little module at the end on Excel. It's on toward the end of chapter 1. And you can, if you want to practice your Excel, do number 11 and 9 through 19 on pages 42 and 43. But that's optional. That's if you want to start, familiarizing yourself with Excel or refamiliarizing yourself with Excel. Okay. Next week is when we're really going to start doing more of what we did with Excel, where we're going to start, solving these. We're going to look at different types of models. This constrained optimization model, it's called a production mix model. It's a standard kind of model, like how much of product A, product B, and product C to make. Okay, but there's other types of models in the business world, like there's a diet problem, there's a portfolio problem, like how much should I invest in these 10 investments? How much should I put here? How much should I put here? Advertising models. There's a lot of models that lend themselves to a constrained optimization model. So we're going to spend the next couple weeks, to tell you the truth, getting past this thing on modeling and working on different examples of models. So we're going to meet at 6:30 next week in the same room. Hopefully the air is working from the get-go. If you have any questions, please feel free to come up and see me. If not, drive home safely and have a great week.
Everybody else.
We did this in Excel a little bit, remember that?
Last night.
Excel, there was like a what if chapter, toward the end where we did the scenarios and the data table.
Yeah, I love it. I'm like,
Yeah, I think I pulled it out because that text didn't do a great job of explaining
yeah,
Excel.
black and white.
I just wanted to.
You know what? Blackboard?
I thought there's office money, too.
Yeah.
Yeah, I spent, I'm just
Okay.
really.